We are going to go over parallel lines and transversals and the angles that they create in this lesson. This black line here is called a transversal, and when it intersects parallel lines, it creates some special angles. We're going to use the word congruent a lot, and angles that are congruent have the same measurement. Okay, so when a transversal intersects two parallel lines, it creates angles with some special properties, like I said before. And the first angle that we're going to discuss is called alternate exterior angles. So alternate exterior angles are a pair of angles that are on the outside of parallel lines and are on the opposite side of the transversal. So a first example of alternate exterior angles, so they have to be on the outside of your parallel line and on opposite side of the transversal. So 1 and 8 are examples of alternate exterior angles, and same as 2 and 7 because they're on the opposite side of your transversal, and they're on the opposite side of the transversal and on the outside. The important thing to know is that these angles are congruent. Or that they have the same measurement. Okay. Okay, so in this example, it says find the measure of the angle in bold. So the angle in bold, if you can tell, this one is a little bit darker. But before we can figure out this angle, we have to solve for x. Since we know that angles have the same measurement, I can set them equal to each other. So 16x plus 8 is equal to 18x minus 6. So I'm going to solve for x first. So I'm going to subtract 16x. So I get 8 is equal to 2x minus 6. Then add 6 to both sides. So 14 is equal to 2x. And then divide by 2. And x is equal to 7. So I found x, but they want me to find this angle because this is the bolded angle. So I'm going to take 16 times 7 plus 8. So I'm plugging that into my calculator. 16 times 7 is 112 plus 8 is 120. So that means this angle right here is 120 degrees. All right, let's move on to the next type of angle. Alternate interior angles are a pair of angles on the inside of the parallel lines and opposite sides of the transversal. Alternate interior angles are congruent. So we have our alternate interior angles. Our first example is 3 and 6. They're on the opposite side of the transversal, but on the inside of your parallel lines. And then we also have 4 and 5. That would be alternate interior angles. So right here where it says exterior, ignore it. It really should say interior for both of those. All right, then let's move on to the example. So if we go back, this said that alternate interior angles are congruent, so that means they have the same measurement. So I can set these two angles equal to each other. So I have 20x equals -7 plus 21x. Okay, I'm going to solve by x by subtracting 21x. So -x equals -7, and then divide by -1. So my answer is x equals 7. But I need to find the measurement of the angle in bold. So 20 times 7 is 140 degrees. Okay, the next type of angles we're going to talk about are corresponding angles. Corresponding angles are angles which are in the same relative position at each intersection where the transversal intersects the parallel lines. Corresponding angles are congruent. So for example, if we look at angles 1 and angle 5, they are congruent because they're corresponding, because they're both on the left side of your transversal and on top of the line. Other example, like 3 and 7 are both below their parallel lines and on the same side as the transversal. Then we also have 2 and 6. So 2 is on the right side and on top, same with 6. And then our last one's 4 is below and on the right, and 8 is below and on the right. So they're in the same relative position. So here we have an example of corresponding angles. So we're going to solve them by setting them equal to each other. So 24x plus 4 equals 25x. Subtract 24x. 4 is equal to x. And so now we need to solve for the angle in bold by plugging that in. So 24 times 4 plus 4. And that means our angle measurement is 100 degrees. Okay, the last ones are vertical angles. Vertical angles are angles that are right across from each other. They're congruent, and they can also be formed in lines that are not parallel. So for example, 1 and 4 are right across from each other in the x. 3 and 2 are vertical because they're right across from each other. Same goes for 5 and 8. And then our last pair, 6 and 7 are vertical angles. So in this pair, we're going to solve this example. And so like the other ones, since these are congruent, I'm going to set it equal to each other. So 14x plus 11 is equal to 16x minus 5. I'm going to subtract 14x. So 11 is equal to 2x minus 5. Add 5. 16 is equal to 2x divided by 2. X equals 8. So we have to solve for this by plugging it in the angle that is bolded. So that one, so take 16 times 8 minus 5. So our answer is 123 degrees. If you have any questions, please let me know. But this is how you solve this example.